Well, good evening everybody, and welcome to second part of the Reloading Live videos I'm planning on doing. Hopefully there's somebody out there, or otherwise I'll just go home and not be listened to by my wife. Drop us a line if you've got any questions. I do have another device that we can hopefully see the messages. I have actually got the camera plugged in this time, so even better. It might not even die halfway through. The purpose of tonight's video is to, in a bit more depth, the resizing of the brass that you will be doing in order to reload. I've got in front of me 3 different rifles, and what I'm hoping to do is demonstrate the difference in the chamber size between one rifle to the next. I used the analogy in the last video that not all size 10 shoes are the same size, and not all rifle chambers are the same size either. The spec for this particular rifle chamber is 308, and as you can see from the highlighted bits, this one here is the headspace. Has a minimum standard of 1.63 inches, and depending on whether you're talking about NATO spec or SAMI spec or CIP spec, there plus and minus element of minimum to maximum. In terms of NATO, they talk about 0.006 of an inch, and SAMI go up as far as 10. Within the boundaries of the different specifications of the chamber, you'll get a maximum and minimum. When you're checking the headspace on a rifle, 2 things that are most commonly used are the go and no-go gauge. These are precision cut stainless steel gauges, which will give you, as this one says, no go there, and that one is go. I don't know if you can quite see the measurements on here. That is 1.634, which is the no go gauge. So if you compare that to the measurements on here, 1.63 is only 1/4 of an inch more than the minimum. And that gauge is expected to stop the bolt closing. Obviously, the opposite, the go gauge, is, I'm not sure if you can quite see there, 1.63. That is the minimum as per the spec on the piece of paper there. If I was to drop this in any one of these 3 chambers, the bolt will close. I'll do it on this one because it's the easiest. And close the bolt, ejects just like a case. The no-go gauge, the bolt should stop usually about halfway. If I really force that down, it will compress the gauge enough that it'll deform it. You've got quite a bit of leverage on here with the length of the bolt. You're really just testing that the bolt with very light pressure will not close. So that chamber is in spec. All of these things have gone through proof to be in the UK and on sale in the past, and they're tested for that at the proof house and various other things. So what I've got here is a once fired case from my own personal 308, which is a Tikka. It's just standard PPU, nothing fancy there, and this was fired from HPS Target Master factory ammunition, which is very accurate and reasonably priced, and on this particular occasion is made in PPU brass. So I've got 3 rifles here. Brand new Mauser M18, it's been proofed, but that's the only time it's been fired, and 2 used Seiko or Sako 85 in 308 and a Hauer 1500 also in 308. And what I'm hoping to demonstrate here is this case is once fired, came out of my chamber, a standard Tikka. If I drop it into this rifle, I'm not actually forcing that, I just need to get it to go over the extractor. There we are. So it closes, very little force being required to close the bolt on that. And he says ejects. Same case in a Seiko 85, or this particular Seiko 85. The next one off the line in the factory may have a totally different spec to this one, but it'll all be within spec. Now this one will not close at all. It doesn't get to the point where the bolts can go down. I'm pushing that forward quite with quite a bit of force, to the point where now it's a little bit stuck. Easy enough. So that will not chamber in that rifle. Chambers in this one relatively easily. This Hauer, I can't even get the bolt flush with the back of the receiver here, so it has an even shorter chamber. None of these rifles have chambers which are out of spec. Hopefully that demonstrates that when you size a piece of brass, if you've got this rifle and you size it to the bare minimum, you are going to get a very large headspace gap comparatively with this rifle compared to either of those. It's not anything fundamental with Mausers over Saccos over Hauers or anything else. It's just that particular chamber, when it was chambered, is within spec, but this spec has a range of 1.63 plus up to 10 thou, depending on the how the chamber was cut and which specification of dies it was cut with. So if I get rid of these for a moment. So I've got a few measuring devices on here. Standard calipers, nothing exciting. They're all relatively cheap and available in any hardware store. Not expensive at all, less than a tenner, the majority of these. That should give you everything you need to know about how accurate they are. The brass in front of me, I've got some more of the PPU. These ones have just been deprimed. I've got two here. One has been full length sized and I've marked it. And I'll show you what we'll do in terms of setting the die up to full length size that. I've set that die up as per the instructions on this die, which is a Lee die. Gives you lots of instructions on how to set it up. And the relevant part here is when you get to this section, sorry, pointing the wrong bit. When you get to this section here, they want you to lower the die a quarter to a third of a turn past the maximum allowable depth of the die in the press, and that is the most that you can size that brass. This brass has been sized as per the instructions, as you would be expected to be sizing your brass if you followed the piece of paper blindly without any other information. So what I've got on this set of calipers is a headspace gauge. The headspace gauge has a predetermined bore to it, which matches the point on the case that the headspace for this particular cartridge is designated. So in this particular case, it is 0.4 of an inch, and that one is marked 0.4. These are Hornady gauges, readily available. You can get a little anvil and get the gauges. You can get the gauges for measuring depth of the bullet in the case and everything else. This one is purely for measuring the headspace. So if we zero the caliper there, now that's set to 0, but if I press on the wheel, I can get 4.5, 5 thou difference just by pushing on that wheel, which if you're ham-fisted or determined to get a particular reading, it's very easy to move these things along and influence the reading. So that's my once fired case. It has been deprimed, but nothing else has happened to it. In fact, I can use that one. The only reason I've deprimed it is because often the primer can be sitting a little bit proud of the primer pocket and give you a false reading when it comes to measuring them. So knock the primers out if you do want to measure them, and it gives you the flat surface of the head of the case there. So insert the case into the die, into the comparator rather, and you are taking a measurement from that particular point on the neck where the headspace has been set or is written to the factory spec. Give the case a little wiggle, make sure it's nice and smooth on the top of the calipers there. So I've got a reading of 16255 on this particular case. Now that's less than our minimum headspace. So there are two things here. I'm thinking, well, either my chamber in my Tikka is way too small, or potentially there's something wrong with these. So I happen to have the minimum chamber size go gauge, which is precision ground stainless and hardened steel, so I'm fairly confident that is within spec. This one's reading 1.621, so 215. We're 7 thou off the minimum spec reading this in the comparator that everyone is reading their headspace from. So just because it says 0.40 on here doesn't necessarily mean you're going to get an accurate reading. Also, with your 10 quid Aldi calipers, does not mean you're capable of measuring these accurately to the level that you need. What you can get is a fairly repeatable figure. So I can measure this 3 or 4 times and I'll get a similar number. 16235, open it up again, close it again, give it a wiggle, 1621. So you can see there's quite a bit of variance in measuring these. Give it another wiggle, 16235. So we're back to where we were before, but there is a little bit of variance in the measurement when you're taking that. So if we assume that we're 6.5 thou off the minimum spec in these calipers using this comparator, and we'll work on that as we go through. So that's my once fired case with the primer in place. That is my once fired case without the primer, and we're back to 716 roughly, which is about where I measured it before and wrote on the side of the case. So you're still measuring under spec, even though I know that actually Tikka chamber, this brass, there's no way my chamber is out of spec, and it's just a consequence of me measuring less than I should be. There you go, it's gone down already, 1625, and I'm not really pushing on that at all. So having a go gauge in this instance is very useful because it gives me a reference point for these calipers and this comparator and everything else. So if you think of that number now, 1625, that's where my once fired brass is. That's the internal measurement roughly of my chamber. Chamber's going to be slightly bigger. As the brass cools down after you've pulled the trigger, it springs back away from the chamber slightly. If it doesn't, then it gives you that sticky bolt, the hard bolt lift and difficult extraction. There is an element of elasticity in the brass even after it's been fire formed. It will spring away from the case, and as it cools down, obviously it's shrinking a little bit as well, even if you are ejecting it with red hot brass. So 25 once fired in my chamber. Here we have the full length sized to the factory spec, to the book, the instructions of the die. Remember, we were 1625 and we are, give this a wiggle, just turn the case and make sure it's nice and flat. You're 1622, so you're 6 thou less than the previous one. Now, on the strength that that's the absolute maximum that NATO spec, and NATO is not necessarily a good example because it's obviously 308 versus 7.62, but you're 6 thou, you're sizing your brass 6 thou smaller than it was already. Now, if it was small enough to come out of the chamber already, do you really need to be sizing it 6 thou? Well, the answer is no, you don't. The main issue with sizing brass too small is if you have a particularly large chamber in one rifle and a tight chamber in another, if you're sizing your brass to fit and you're knocking it back 6 thou, when you put it in the rifle with the large chamber, you are going to generate a headspace issue. Headspace of 5-6 thou is not necessarily a problem, but if you have a slightly oversized chamber that's already 3 or 4 thou bigger than the other one, then all of a sudden you're getting into 10 thou more and more. It may not present any issues in the firing of the ammunition or anything else, but it is working your brass more than it needs to be. Now, this is an alloy of copper and zinc. There's nothing fancy to it. Different brass manufacturers have different materials, different alloys, different percentages of one metal over another, different thicknesses. They all have a slightly different elasticity. The issue with sizing brass to the very minimum spec of its chamber spec it then firing up to the very maximum and going through that cycle all the time, is you will work harden the brass and it loses its elasticity. The two main things that's a problem with are, one, it doesn't seal in the chamber when the rifle goes off, when the cartridge goes off rather. It's lost its ability to flex and seal properly. You'll get a lot more black on the side. It should not come past the neck. Some of these you can see it's already been cleaned off, but you'll see that the black marks around the neck, which indicate where the soot has stopped. You do not want that to come down onto the shoulder. If you see that in any case, then start questioning whether your brass integrity is still as it should be. The other issue with work hardening is it will not be gripping the bullet. The neck tension in the fully made up round will not be the same from one round to the next. Now, I firmly believe that neck tension is probably the most influential element of any reloading. The quality of your brass and how you prep it and making sure that the bullet is being gripped in the neck consistently from one round to the next is the reason that you have accurate ammunition. You can be off with your powder charge, you can have a few extra kernels in here, there and everywhere. It won't make as much difference as it will if you have variable neck tension. And that's one of the reasons why we try and use quality brass. PPU isn't bad. It does have a tendency to be fairly high spec, so it's at the upper end of the SAMI or CIP spec chamber. And if you've ever bought PPU ammunition, you may have had situations where the ammunition itself won't chamber. So on that point, if we zero those calipers again, I've got a box of Hornady match ammunition here, 168 grain hollow point boat tail, nothing fancy, fairly bog standard ammunition. It's live. If I try not to drop it, put that into here. Now, bearing in mind we were reading probably 5 or 6 thou lower than we should have been compared to the absolute measurement on our go gauge. So we know that was 136 or 1634, and we were measuring, I think, 5 or 6 thou lower. So this is showing 1626. So if we were to put that, using the assumption we were 5 thou under on these calipers, we're back into the middle of 1634. 1631 or 2 maybe. So you're in the middle of the spec for this chamber. 1632 would put it right in the middle of roughly a 4 thou or 6 thou range of chamber sizes. So Hornady know that this round has to chamber in everything from a very tight chamber, which would be unusual if it was right down at the bottom of 1630, but it would also fit a rather oversized chamber, but without giving it too much of a headspace issue. So most factory ammunition is created so it's bang in the middle of the spec, whether it's SAMI or SAMI or CIP, which is the European equivalent of the American SAMI chamber spec. So what does that mean in terms of your setup? So we've got a number of different dies here. I'll try and do this on the video. So if I look at these over here, we've got a Lee die. There's a full-length die already in the press. This is a Lee full-length sizing die. The inside of the die is obviously chamber spec or near enough, with the exception of the neck, which is not. It's tighter and it's designed to squeeze the neck of the case down below the size you need it to be. And in doing so, that brass has to go somewhere. So if you take a case and squeeze it in a die, it's got nowhere to go. It can't go down because you're pushing the case up from below. It has to grow. So you'll get the case, each time you size it, it will grow slightly. Again, another reason why, if you're sizing to the absolute minimum spec of the chamber, you're getting your case to grow as much as it possibly can every single time you size it. Now, if you are then following the guidelines of the chamber the maximum trim length will increase. Every time you size this, you're removing a bit of brass. Every time you're removing a bit of brass, you're removing a bit of the integrity of this case. It's getting thinner. More often than not, down where it receives the most amount of pressure, which is down in the webbing, that's where you get issues in several times fired brass, where the case head can become separated because this area becomes thinner and thinner because it's been sized and sized and sized and trimmed and trimmed and trimmed, and you've lost some brass. So the outside diameter or the inside diameter of this die is no different to any other full-length sizing die. What differs on this one is it has a one-piece stem. So in this scenario, let me just get a deprimed case. The case will slide over the pin. You can see there's plenty of movement there. There's no issue at all. The pin comes through the bottom of the case, knocks the primer out, and when it gets to about that depth, it's sizing the neck below what you actually need it to be. And the action of removing the case from the die drags the neck back over this expander ball. So it's obviously got a long taper on this side, allowing any size case to go in this way, and a much sharper taper on this side. And if you look, you can just about make out that there's residue of brass that the pin has removed. Now this is just a steel pin. It's not particularly smooth by the look of it, but it's smooth enough that it's not going to damage your case, and but it is rough enough that it's removing material. It's removing, whether it be carbon, a bit of brass, and it's one of the reasons why you need to lube not just the outside of the case for forcing it into the full length die, but the inside of the neck when it's dragged back over the expanding ball in this style of die. So the other option is a full-length die. This is a slightly more expensive version. Redding dies are very, very high quality. They have slightly different makeup. They have an adjustable expandable, can be removed. Good thing here is if you snap the pin, if you've missed the primer pocket hole as you overzealously size your brass on a Saturday night, you've snapped the pin. What do? I just get another pin, unscrew this, new pin in, ready to go again. With the Lee die, if you snap the pin, this is one piece. Once that's broken, it's disposable. But the difference being, these are cheap and these are rather more expensive. Slightly different profile die. A lot of higher quality dies have different materials used in the expander ball. You sometimes get titanium or carbide. The colouring on some of them, the internal components of some of the dies is a dead giveaway. The sort of yellowy coloured bushing dies that I'll show you in a second are titanium nitride. It's not only very hard, it's actually very smooth, and also aids the brass going over the top of it. Now, as the case goes into that die, it's obviously squeezing it smaller than it needs to be. It's then dragged over that expander ball to the size that the manufacturers are hoping will give you a repeatable neck tension. So that is the same design as the Lee, standard profile internals with a slightly undersized neck, dragged back over an expander ball, and that's where you get your sizing from. Another Redding die, this one is a bushing die. So as you can see, titanium nitride bushing, it comes with a specific size. Now Redding produce bushing dies in 1 thou increments, so you can have a full list of bushing dies. They're rather expensive. Off the top of my head, they're about 25 quid just for that one component. That component goes inside the die. You can just about make out there's a recess in there for the die to go in. Similar expandable, the only difference in this one has an adjustment collar that allows you to lock the die down regardless of where the expandable sits, so you can make sure that there's no movement in that die, and it's going to size the neck of that case. Now these are not 308, but I'll give you a quick rundown. If it was a 308, the way to set these up is you take a loaded round. In this case, these are 6mm BR. I've got two dummy rounds here, one with a 75 grain VMAX and one with an 87 grain Hornady soft point. They're just dummies. There's nothing in them, no powder, no charge, no primers. This is purely to give me an understanding of when this bullet is in this case. I want to try and get an accurate measurement of the outside diameter of this neck. So I'm looking at 686. I'm turning this case to try and get a better idea. That's in millimeters, we don't want that. So 270. That's the outside diameter. That's the diameter of the bullet plus the two sides of the neck. So we're 270 on that case with the VMAX. They're both Lapua as far as I can remember. No, both Norma, sorry. And remarkably, despite the fact these are two completely different bullet designs, and they're both at 270. So in this scenario, Redding suggests that you go down 0.02 of an inch to the next size down. So what I should really have here is a 268 bushing die, which would give me what they refer to as 0.02 of an inch of neck tension. Well, my physics is a bit rusty, but neck tension is not measured, and the elasticity of a particular metal is not by a size. It's measured in gigapascals even, and it's very variable. And depending on how many times you have fired that brass, who made the brass, what alloys they're using, you get differences in neck tension because of the quality of the materials you're using. You're also expecting that brass has a uniform neck thickness all the way around. So you'll often see, if you've trimmed your brass, you can see where the top of the case is at its thickest when you've taken the trimming off, and you can visibly see with the eye that one side of the case is slightly thicker than the other. It's much more prevalent in cheaper brass, obviously. You know, we spend a lot of money on Lapua or Norma or various other brands of premium brass to make sure that it is the most consistent, and we do have this uniform neck thickness, which is giving us a uniform clamp on the bullet of a uniform type of alloy. The quality of the brass, we've possibly annealed them to make sure that they've put lots of spring back into this case so that it is gripping the bullet in the same way each time, every time, and that's what we're trying to achieve with repeatable die setup, as well as the quality of the brass, and making sure that we're not working with hard brass or substandard brass that has slightly different thickness on one side to another. Two issues with that. One, it's not gripping the bullet the same way all the way around, but also your bullet's not sitting concentrically to the bore, assuming that this case is sitting in the bore concentrically. You'd be surprised how many chambers don't have a bore that is concentric, a chamber that is concentric to the bore, depending on how the barrel's been made, who's made it, or the quality of the materials used. So we've done the thickness of the neck. Now, if you decide to go down the route of neck size, the only difference with the neck sizing die is you have a number of different ways of doing it. So this is a Lee collet neck sizing die. Clues in the name. Inside it has a collet. If we take this apart, we can push this out, and you have a split collet, which has 4 fingers there. If I push the case in like that, it will go up into the collet just about. I need to push it a bit more, but it won't go in by hand. As you compress the die, this collet section is driven up into a tapered section, which crimps the top of the neck around a pin. Now that pin is a specific diameter. In the same section, they are expecting you to have a certain amount of neck tension because of the diameter that they've set this to. Now, you can whiz this down in a drill with some very, very fine grit paper, emery paper, to get a slightly tighter neck tension. And depending on how thick your bullet is, you will always get the same neck tension on this die because it's using the inside diameter. So the brass going over this pin can only go down as far as the diameter of the pin. So these dies are quite like. They are cheap, they're very repeatable, but the best thing is it removes one stage of the reloading process, which is the lube and removing of lube from the case. You can run these just straight out of the box. You've got an empty or used case with a primer in. This does the whole lot in one go, knocks the primer out and sizes the neck. You can turn the case and do it again. What it will leave you is with 4 little marks. You can just about make out the original factory crimp marks on this, that little ring around the top of the neck there, and possibly some little indentations showing where the collet was. There's one there. That's the original factory crimp on this particular case. This is working in the same way, but it's working right down on the neck down here. So that doesn't touch the body of the case, doesn't touch the shoulder. It's very useful if you're using brass that you've pulled out of your gun. You know that they've been through your chamber. If you imagine the 3 scenarios of those rifles there, if I was to take brass from the Mauser and try and neck size it and put it in the Seiko 85 or the Hauer, just wouldn't work. It would work if I took the brass from the Hauer, neck sized it, and put it in the Mauser, because we know that the Hauer had a slightly smaller chamber. So there are some workarounds there, but on the whole, you want to be using brass from your rifle, all the same head stamp, same brand. They're all going to have the same thickness, and neck sizing in that scenario will give the amount of work to the brass, and it will stay the same size as your chamber within reason. If you're running very, very hot loads or very high pressure, your case will, after an indeterminate number of firings, maybe 1 firing, maybe 5 firings, it will become sticky. It's not small enough to fit in the chamber without a certain amount of pressure on the bolt handle, and you'll need to full length size or bump the shoulder back to accommodate that brass in your chamber. So this one's a full length size one, and I think if we rotate it in the light there, you can see there's a brightening mark where the finish on the brass has changed, and there's a ring starts here and it's taken in the entire body there, and also there's a very sharp color change on the point of the neck here. So you can see that case has been through the full length die, and it's done the entire body. It's also done the shoulder and obviously the neck, because that's what we want to hold the bullet in. So if you're sizing your brass this much when you don't need to, that brass is going through a cycle, a work hardening cycle, and the entire case is getting harder and harder and harder, and depending on how much you do it, weaker. If you bend your spoons and forks back and forth at the neck, they're going to break. And this is the same cycle. You're trying to maintain the elasticity in this piece of metal, and the best way to do that is to not move it. If you have a case that's constantly being squeezed down, sized out again, fired, resized, squeezed down, and back and forth, you've got 3 or 4 cycles in just one firing. So obviously it was this size, you put it in the case, it's then got bigger when you fired it, you've then forced it into a die, it's got smaller, you've dragged it over an expandable, it's got bigger again, and then you've seated a bullet which has got bigger slightly more. Is going to put quite a lot of work and stress through the metal, and you will get a lot more brass life, a lot more firings out of your brass, and consistent neck tension if you maintain the minimum amount of sizing when you set your dies up. And we'll go through that shortly. So that's a collet neck sizing die from Lee, no lube, very simple, does what it says on the tin, there's nothing exciting about it. If I was to take the neck sizing die from Reading, that's a standard neck, and if you look on the side of the die, if you're unsure which one you've got, they're normally marked. This one just says NK, very straightforward. The other one will say FL, full length and neck. The neck sizing die, the internal chamber is slightly bigger. but obviously the neck element is the same as your full length die. It's going to compress the neck to a point where it's smaller than you want it to be. It's got the same expander ball inside. Drag it back over the top. It will be roughly 2 thou smaller than whatever bullet or caliber you're currently working with. And this die will require some outside lube, because obviously you're forcing that brass into a steel die. It's not sizing the whole case. It's going to be a lot easier than with your full length die, which is taking in the whole case and the inside. This one, inside and outside of the neck, is usually enough, and it's just enough to size it without touching the rest of the body. A lot of people are very against neck sizing. Will say, well, if you're in a hunting application, you want your rounds to chamber smoothly and have no bolt tension at all when you're chambering them. That's a function of you setting the die up and also having quality brass and not having run extremely high pressure loads on brass that is already getting hard and has lost its elasticity and its ability to spring back. I neck size most of my cartridges for a whole range of calibers, from treble 2 up to magnums, and it works extremely well, but very few of my loads are very high pressure loads, so they're not getting the work hardening that you will see if you go through numerous stages of resizing. This neck size is sizing the outside of the neck. The Lee die is sizing using the inside diameter as your reference point. So this die has a specific fixed internal diameter. If you have one case that has slightly thicker neck, if you size the outside, the inside hole is going to be smaller. With the Lee die, doesn't matter how thick your neck is, you can't go smaller than the pin. That's one benefit of the Lee die over a Redding die, but if you're already investing heavily in Redding dies, you've probably gone to the point of choosing brass which has very consistent neck wall thickness. You might have gone down the route of neck turning, which we're not going to touch on today because that's one more rabbit hole to go down to. You've got two neck sizing dies there. You've already introduced a variable. One is fixed on the internal diameter, one is fixed on the external diameter. That's going to introduce a variant in your neck tension straight away. We looked at the Redding bushing dies. Obviously they have an ability to run the bushing on a neck die as well, and if you set the depth of your die, full length sizing die, you can utilize this bushing, only size half the neck if you want, depending on how far you want to go. There is a benefit to that. Obviously you're only working the smallest amount of the neck. I'm not truly convinced that it's worth the effort or the expense of going to bushing dies just to size half your neck. I'd also like to see a full neck size, because it's going to give me the most amount of concentricity when a straight-sided bullet shank is in that neck. I don't want it to be gripped just at the top edge here. I want it to be gripped all the way along, and in that way I'm going to get a more consistent neck tension. Again, I firmly believe that is the most significant aspect to the accuracy of the ammunition that you're making. Which brings me on to the cheap and cheerful neck sizing tool. So this is a Lee loader. It is my Lee loader. I drilled this block of wood for the purposes of using this in the shed, and they work extremely well. It's a very simple thing to use. I've got a once fired case here. The Lee loader is made up of the die itself, which is usually preset ready to go. That is no different to any other sizing die, with the exception of it doesn't have a pin down the center for any other sizing. The case goes into the die, but as you can see, it's bottoming out on the neck section, and coincidentally that depth there is roughly about the depth of the neck. So the process for this is again outside neck. So I haven't seen one of these before. I'll try and do this without knocking the camera off. That's what the wooden mallet's really for. So very easy, very simple, a bit daunting when you first do it, but it's fairly straightforward. Whack that case into the die. So it's nice and flush, and by forcing it in, you've sized the neck, and that's left you with, apart from the fact it's left you with a case stuck in a die, it's left you with a neck-sized die to the outside diameter of that case. So again, if you have any variance in the neck width or the thickness of the necks themselves, then you're going to get variable neck tension, because a thicker neck case will have a smaller hole, and therefore by definition it might be introducing more neck tension. So next stage, get the case out the die. I've actually done this the wrong way around. I should have deprimed this first, but never mind. Assume that I've deprimed this case first. And that is your neck-sized case. If I can try and focus on that. Brightening marks on this case again, predominantly on the neck. It's got a few scratches, vertical scratches as it's been forced in. Obviously over time it's full of carbon, and it will build up carbon residue, which will work like carbon paper sand and rough up the outside of the case. But that case is pretty much ready to go. Assuming it's come out of your rifle, you can be fairly confident it's going straight back into your chamber with no issues. If I'd done this in the right sequence, I would have knocked the primer out on this tool here. I suspect that's not going to fit in now. It's not. There you go. The seating of the primer is fairly straightforward. This little tool here, individually put a primer in there. It's got a sprung plate. I don't know if you can see that. So that when you put the primer on, it'll sit in the little groove there. When you put the case in, using the die, it will sit over the primer. And when you use the pin to whack it down onto the primer, you can see the bit of spring in there. It will seat the primer into the case. That's possibly the most scary part about doing any of these with the Lee loader, but actually it's I can count on one hand how many times the primers have gone off, and it was my fault because I tried to put two in at once. But the seating of the primer is fairly straightforward, and that's it. Case done. No lube, no messing around, no press, no extra tools. If you've got a case conditioning kit, you can check the length, but if you're using once fired brass from your rifle, then you're pretty safe that if it's come from a factory, one firing's not going to lengthen the brass to the point where it's excessive. So you don't even need to trim these the first time. It's always useful to check, but in terms of kit that you can start reloading with, this box, there you are, 35 quid, has everything you need in it. Decapping pin, the holder to allow you to put the case in so the spent primers go through, and I have a, if it'll come out, a hole drilled in this, and it goes through, right through the block into the bottom where there's another hole, so all the primers just go straight through, and at the end of the reloading session I just sweep them off the bench into the bin. Pin to knock the case through and also seat the primer. This comes with a scoop, and this brings me back to volume measurement of powder, which we'll touch on when we get into the next stage of setting them up. But this particular scoop is a 3.cc scoop, and 3.4 cc scoop. They've got a list of powders that you can use where you can pretty much jump straight in, shovel in 3.4 cc's of Reloader 15 with a 90 grain bullet. You're going to get these figures. It gives you quite a range of bullet weights that you can use. Same thing, change your powder, change your bullet, use the same scoop. When I started reloading, I had one of these for two different cartridges, and the whole lot with two sets of bullets and two different pots of powder and everything else I needed fitted into a shoebox. So if you're on a budget, or you're running out of space, or you're looking to do this just as a tester to see how it works, then very useful kits to get into. And I managed to produce or replicate factory ammunition, which went from roughly 3/4 of an inch group with Norma 270, 130 grain, down to less than half an inch just by using one of these. The die is adjustable, so you can set the seating depth of the bullet. Once the case has been sized, put it in there, chuck your powder in the top with the scoop, drop the bullet in, and then a seating pin, and conveniently designed so you can whack it in with a wooden mallet. And then your loaded round just pops out the bottom, ready to go, and yeah, very accurate, very simple. So it doesn't always have to be extremely expensive to get into any discipline of reloading or anything else. So I will try and move the camera so we can set the die up to make one case for one of those rifles, and you can see how I would set it up, and it'll hopefully give you an idea of changing the way you set up your die to maximize not least your brass life, but also to give you a case that is repeatable, safe, and hopefully more accurate. Some of the bench rest disciplines, the cases they use are not sized at all. The chamber is very, very high tolerance. The neck of the chamber is actually quite slack. There are a lot of people who compete in bench rest who won't size the neck at all. The brass is literally there to hold the bullet very loosely, and the bullet is seated into the case finally by the chamber itself. So it's touching the lands as the case is loaded, pushes the bullet into the case. There's no neck tension whatsoever. Now obviously that's not applicable to the majority of people because they're shooting in the field, they're shooting in unusual circumstances, maybe unusual weather conditions. You can't have a load of bullets in your box, a load of rounds in your box where the bullets are not seated properly or they're loose. It's got design for it. But under the very confined and restricted terms of bench rest shooting, that is something that they can do to completely remove any variance in this case whatsoever. Neck tension is no longer applicable, they've got rid of it. Brass quality, doesn't matter how many firings it's had because we don't care anymore, we're not loading it for neck tension. Trim length is important, but ultimately that's a very, very unique discipline. So if I find one of these rifles, so we'll go with this one. We know that brass was too large to fit in this chamber previously. I'll just double check this is the same case, PPU. It's once fired. I'll give it a see if it chambers. Am I on camera? Yeah, there we are. So can't even get the bolt anywhere near closing. It's just not going to chamber. That is a very large piece of brass for this rifle. So if I was to set this die up, and I'll try and do that so you can see the die and the rifle without moving the camera. The instructions in the Lee kit will tell you to, there's your full length sizing die. So we've got a 308 full length die. It's got your decapping pin protruding. It doesn't really matter how far out this protrudes, so long as the pin is still well inside the die and it's not going to interfere with the inside of the base of the case and the head and the webbing around the thickest part of the case here. So 1/4 of an inch or whatever that is sticking proud is fine. So follow the instructions. The Lee instructions will tell you drop the press handle and screw the die in until it hits the, if you back the collar off you can see where it's hitting the die. It's an interference fit. If I drop the press you can just see where the shell holder, now these shell holders come with these dies. In this situation, this Lee shell holder, they're all fairly similar in shape and size. Universal presses between Lee and RCBS and Reading, whoever makes the press, they want the shell holders to be interchangeable. What differs between them is this, which is critical. This depth here on one brand to the next brand could be the difference between your case sitting in the die to that depth or slightly deeper. So bear that in mind when you set up a die with a particular shell holder. If you happen to have lots of different brands of shell holder, then you might end up finding that you can have very different overall dimensions of the case just because you might have swapped the wrong shell holder out. So follow the instructions. It says whack the press arm down, screw the die in, lift the press arm up, and if you remember in the instructions here it said, I can't actually recall whether it's a third or a quarter. So sterling sizer until it touches the shell holder, which we've done, then lower the arm, and screw in the die a quarter to a third of a turn. So if I demonstrate what that does to the arm, arm down, press is there, the die can't go any further. If I lift the arm out the way, so I can screw that down, if I go 1/4, that's about 1/4 there, the arm will not go down to its full extent. If I really push it, it will cam over. It's going past the point where it's vertically aligned, and it's just actually a joint in the press. The press can't go the shell can't go any deeper in the die because the shell holder is fully up against the bottom of that die. So when I size that case that we measured as being 6 thou less than it really needed to be, that's the full length one there, that's the operation I followed. I followed the instructions, and it gave me a case that will fit in any one of those chambers. But I can guarantee you, if I put it in the Mauser, I'm probably over 10 thou smaller than I should be, because I've sized this case to the absolute maximum I can do on that die, and it couldn't get any smaller. Now, if you imagine you've got 3 chambers there that have been cut in Friday or wherever to different tolerances within that range of the spec of the chamber dimensions, move that to the die and do the same thing. Now imagine if you've got a chamber that is extremely large, like the Mauser, for example. It accepted brass from any one of those 3 rifles, including a 4th rifle, which we haven't got here. If you have the opposite with the die, and it's the smallest possible end of the scale, or maybe it's even smaller than it should be, but you won't know that because you have no way of measuring until you've sized that brass. You could start influencing the overall headspace on this case by as much as 15 thou, and then things can go wrong. So rather than following the instructions, which no bloke ever reads anyway, we're going to do it differently. So arm down, wound the press, wound the die into there. I'm not going to screw it down even more. I'm going to screw it down even less. In fact, what I'm going to do is I'm going to use this one without the pin, which I had here for a reason. So I'm not really interested in sizing the neck at the moment. All I'm trying to work out is how far I need to screw this die down to get it the minimum amount of sizing and shoulder bump that I can get. So I don't know if you can see from there, I've still got a little bit of the die. Camera's moved, sorry, bear with me. I've still got a little bit of a gap here between the die and the press, plenty of space. It can't screw down anymore. So I've taken the pin out of this one. This is the one I showed you earlier. So there's no expandable to expand the neck back out. I'm not screwing it down, I'm screwing it up. Probably more ways than one, but we'll see. So back it out a full couple of turns, I would say. I want that die to be sizing less than it needs to be. There's my once fired case, still got the primer intact. Now it doesn't matter that this one's not going to take the primer out, because this isn't the case I'm actually going to use. All I'm using this for is to set that die up. So I'll get rid of this so you can see. Same case, double check it's the same one. Get in. Bolt won't close, no chance. It's sticky to pull back out because that is so oversized, and you can see some of the marks that the chamber is leaving on the case, brightening marks just from me forcing it into a slightly undersized chamber. It's rough, it's got streaks on it, scratches just from the soft brass against the steel. So I'm going to have to lube this case because it's going to be forced into a die that's going to be squeezing all of the body. So this is the Lee tube, nothing fancy. A little bit on your finger there is enough to cover plenty of cases. I probably put too much on there, but all I'm doing is spinning the case, making sure there's plenty of coating there. If you were sizing the neck, just dragging your finger across the edge will put a little bit of lube around the lip of the neck there, so that when the expandable goes through, it'll drag some into the neck. It's usually enough to get it going. Now, various lubes you can use. Lee have a tube of this stuff. They used to do a lube in a can called Hornady One Shot, which was great, but you can't get it in the UK anymore. And it's just a quick squirt on all the cases all at once, leave it to dry, and it was fantastic. Very clean, neat. Hornady Resizing Wax. There are various other resizing waxes you can get. Same deal, rub some on your finger, put it on the case. Make sure it's got a very, very light coating on there at all, so that you can't even see it. Much more than that, and you're going to start leaving residue inside the die, and to the point where if you get a build-up of residue, you'll find every now and then you'll pull out a case here and it's got a dent in the neck or a dent in the side, because you've hydraulically pushed that case in from the outside with a lump of dye, lube on the inside of the die. So we don't want too much there. Other ways of doing it, case lube in a bottle. A lot of these are lanolin based. You just give it a quick squirt on a pad and the pad to rub the case in it. It doesn't put a great deal on, it's just a sponge, and it's enough to stop your case getting stuck. If it does get stuck, it's a ball ache. So just to make sure, I'm going to back that off one more turn. Make sure your case is pushed right into the shell holder. I try and offset the shell holder so I'm not having to push it past the leg of the press. You've got lots of space to go inside here. And I'm pushing down. You can feel it going into the case, into the die, sorry, and it's sizing. This box is loose, so I'm just holding onto the press like that. So what I've done is, if you can see how far this case has gone in, and it's only sized the neck. So right there you can see the extent that the case has gone in. So I know I'm miles away from where I need to be. I'm not even touching the shoulder. So despite the fact that I could use this case, assuming it was primed, it would grip the bullet because I've sized the neck. The bullet, even though this hasn't had an expandable, the bullet will, if it's a boat tail fairly easily, it will expand the neck to the point where I can use it as a case, using the die as a neck sizing die rather than a full length sizing die. But as this hasn't touched the shoulder, it's not going to chamber. Ah, it is going to chamber. All right, I'll take that back. So what I would expect to happen normally when I've sized the die is I don't see any interference on the, there's a little bit of interference on the body here. If you back that die out even more, you'll get less interference with the body of the chamber. So take another case, hopefully this one, that one's a bit sticky. Back it out even more. And see if that has sized the body of the case. No, right, so same situation, but I've actually backed the case out. I've backed the die out even more, so it's not sizing the body of the case. So that's sticky, bolt won't close, but again, you can see that it has sized the neck of this case a little bit more extreme. You can see the lip, but it hasn't touched the body of that case at all, so it still won't chamber. So I'm going to give it another half or 2/3 of a turn. Keep sizing that. Pretty sure that hasn't touched the neck either, or the body of the case either. And I'm going to keep going through this process, turning the die down. Because I haven't got an expandable, don't need to keep lubing this all the time. I'm not too worried about how this case looks. All I'm really looking for is a depth measurement for this die. So it's a little bit deeper. I can get the bolt a little bit further down, but there's still tension in that when I'm trying to close the bolt. Give it another half turn. Try again. Still a little bit sticky, but I'm not putting too much pressure. It'll go further. I could compress that all the way down and actually use the chamber to size the die because I'm almost there. A little bit of a half turn there. I'm starting to see a few marks on the outside of the case where it's touching the inside of the die and sizing the body of the case. A little bit smaller, and I'm just going to keep repeating this. Half turn. Now obviously this is specific to one brand of brass. So the case that I sized before was PPU. This is actually another one from my same 308, but this is Triple G or GGG. So I think it's Serbian. They make a lot of cases for the military. They also make them for various target disciplines. So size that again. I could probably close that, but I'm not going to. Give it another half to quarter turn. And just keep going until you get to the point where the bolt closes. No, I'm not going to force it. Bolt just closes on that case without any obvious resistance, so that you're not using the rifle bolt and the chamber to size the brass. If you can see there, we've got a slight ring at the bottom here near the webbing and the head of the case. A few little brightening marks just on the very edge of the shoulder, and you'll see the neck sizing element is coming further and further down to the junction of the neck and the shoulder there. So I don't know if we've tried that one already, did we? So back in the press, another half quarter turn. And because there's no expander ball, I'm not really stressing the case too much, but actually this is going to be a reference case. So again, I'm not putting a huge amount of pressure there. I could close that bolt, but I'm not going to. I want to set this die so that it's just sizing for my chamber. And as you get closer to the limit of your chamber, you can start turning the die slightly less each time. I'm just backing that collar out so you can see where it gets to. Another half turn. So much for the magnet. Right. Hopefully we're getting there. There we are. So, we still on camera? Yes. That is no pressure at all. You can close that bolt, one finger. I turned that probably half a turn at the very end. If I'd been going a little bit more patiently, I'd have done it a lot less, to the point where it was maybe a quarter of a turn. So that brass now fits just in my chamber. It's the least amount of work I can put to the outside of this case, and it's the best fit for my chamber. Now, I'm not a bench rest shooter. I don't claim to be an expert in reloading, but from the simplicity of making sure that that case has the least amount of clearance between it and the chamber, I'm going to get more concentricity between the bullet sitting in line with the bore. I'm going to get a lot less work hardening of this case, and it's going to be easier to reload in future. I'm going to be trimming less. I'm going to get more firings out of this brass, and being tight-fisted, that's probably the main reason I do this. So you can see the annealing mark on this case. It's not going to need to be annealed as many times as a case that I've done using the absolute full length method that Lee suggests. Just to demonstrate, that is perfectly sized for my chamber. In theory, this should be a world away from the die, but it doesn't look like it is actually. So try and size the brass less than you would do if you followed the instructions. and end up with a case that is perfectly matched for your chamber. There are numerous makes of that you can use. At my level, I certainly don't think I'm getting the most out of a set of dies that costs 180 quid over a set that costs 50 quid. I am getting fairly repeatable results, but I'm not competing with the ammunition that I'm producing. You'll get to the stage where if this becomes a big part of your shooting, then you'll start investing in better and better equipment and using more and more of it to make sure that you've measured and you've got all the variables out of the system. A lot of those variables are as much to do with the mental games of you behind the rifle with your finger on the trigger, knowing that you've removed as much as possible from that reloading, and that it's down to you. It's not down to any variable in the extreme spread or the standard deviation or the muzzle velocity of one particular round over the next. It's down to you and when you pull that trigger. So that's it for this evening, but I will happily answer any questions anybody may have about the sizing part of it. Once we've gone through this part, I'll move on to preparing the case after the full length size and what you're going to be doing with it, charging, and how you're going to set up the dies to seat the bullet and where you will get the information from to make sure that you're not seating the bullet too long, too short, which will by definition will affect the pressure of your cartridge. So thank you for watching. If you have any more questions, please feel free to drop us a line, and now you can get back to the rest of your isolation. Thanks very much.